Welcome back, students. In this part, I'll be telling you about redox titration. What actually is titration, okay? And different types like idiometric, neutralization, etc., etc. So these all things we're gonna study here. These are actually nothing but these are the application of oxidation number and equivalent weight concept only, which we have already studied in the previous parts. So let's start it. Next, guys, is redox titrations. Titration becomes very important when you have to find the concentration of any unknown compound. Means compound be known, the concentration is unknown, okay, and with respect to something, some standard of which the concentration you know. So redox titration becomes important that time. You must be doing titration experiment in your school labs also. So redox titration, what is first of all titration? As I told you, the process of determining the concentration of any solution by adding its known volume to react with some another solution of known concentration or known strength. So some common examples are, which we take is potassium hydrogen phthalate, which is an acid base type. Again, anhydrous sodium carbonate, which is again an acid base type, potassium dichromate redox type, arsenic oxide redox type, potassium iodate redox type, sodium oxalate redox type. So these are the common solution we take whose concentration is well known, and we do the titration against them. So the main aim of titration is what? Addition of quantity of any standard, which is these are the standards, and solution chemically equivalent to that of quantity of any unknown. So what are the types? Types is, first of all, acid base, or I will say neutralization titration, when it involves a neutralization reaction, okay, and the type of indicator which depicts us that the endpoint has achieved, that is the pH of that endpoint, okay, pH. Second type is a redox type. So in redox type titration, which involves oxidation and reduction, that is a redox titration. So the completion of the reaction is often indicated by change in the color of the reaction mixture, okay, which may be either due to the change in reactant color or maybe the substance which is externally mixed, which is known as what? Indicator, which is known as indicator. So indicator study we will also do. Third type is your precipitation titration. In precipitation titration, what happens? You have two such solutions which are mixed during the course of that experiment, and the end point it is obtained, and when it is obtained we saw a precipitate is formed. Okay, we saw a precipitate is formed. So that type of titration is known as precipitation titration. It is like this. Suppose KCl plus AgNO3 reaction is this. So you obtain a AgCl. This is a white precipitate which we obtain. Okay, this is a white precipitate we obtain. Similarly, Ki plus AgNO3 again AgI. This is also white precipitate. So this type of titration is known as precipitation titration. So some titration which involves silver or nitrate are also known as what? Adgenatometric titration. Okay, so you have to remember this word, adgenatometric titration. Okay, Ag, silver one, argenta, because they are what? They form the insoluble white precipitate. Next is iodometric and iodometric titration. So these reduction of the free ions to iodide ions and oxidation of the iodide ions to the free iodine. So let's see what are these. This is your reduction part, okay, which is your iodometric part. This is your idimetric part, 2I minus. This is reverse reaction. This is reaction. This is what? Oxidation with respect to iodine. So in iodometric titration, what happens? Your free iodine, which is this one, I2, okay, I2, it against the standard reducing agent, it is titrated with some like sodium thiosulfate, any halogen, dichromates, okay. Then these cupric ions, peroxide, these things can be estimated by these methods. What happens? Your I2 is added with Na2S2. This is what? Hypo solution. So it forms NaI, and when this is react with Ki again, I2 is get released. So this is your iodometric part, this is your ID-metric part, like this. ID-metric titration are what? These are the one in which free iodine is used as it is difficult to prepare the solution of iodine, which is volatile. Okay, volatile means what? As soon as you just place them, it will get evaporated in air and less soluble in water. So dissolve in what? Ki solution. So Ki plus I2 gives you Ki3, and this solution is standardized before use. What do you mean by standardized? Standardized means I have some standard concentration of that solution. Okay, and from this I can find sulfide, thiosulfate, arsenic, etc. concentration. So in the ID-metric and iodometric titration, star solution is user indicator, which I was talking about indicator. That was actually what? Star solution. Because star solution gives what? Blue or violet color with free iodine. This is a property. Okay. So at the end point, when I will obtain blue or the violet color, which is getting disappeared, then I will say that iodine is completely changed into the iodide. Okay, iodide. So star solution is your indicator here which we use. Next is volume strength of H2O2. So volume strength means what? If I take X liter, then how much is the oxygen I will get? Okay, X liter of it, then how much is the oxygen getting released? Like this way. This is the equation, 2H2O2 gives you 2H2O plus O2. So from this, if I take X ml of this, so how much O2 I am getting from this, that is your volume strength of hydrogen peroxide. So you can see 68 gram, okay, 68 gram, and it is giving you 22.4 liter at STP, oxygen, okay, oxygen gas volume. So 22.4 liter is given by 68 grams, so X liter is used from what? 17 into 5.6. So this is the strength, this is the strength. So S is what? Strength, that is equal to 17 X divided by 5.6. This is not into, this is what? X, as I have taken X liter, okay. 17X divided by 15.6. So normality is equal to what? Normality is equal to S by E. So that is equal to 17X divided by 5.6 into 34 by 2. So that is equal to X by 5.6. So from here you can find out that X, the volume strength, that is equal to normality into 5.6, okay, for H2O2 solution. So this is the last topic of Redox titration. We titrate against H2O2 also to find the concentration of the respective species. Hi students, so in this part I told you about the titration, right? What titration was, how do we find the equivalent point, okay, there are some indicators also. Also we find different parts of titrations like iodometric, ideometric, neutralization. Also there was color change in between, that is at the equivalent point. So I hope you get this concept clearly well. Now there is one more application of oxidation number, which is actually combining the whole cell, known as electrochemicals.